Now we're working on the check for understanding, which is sampling distributions for proportions. So this is a little bit challenging because we're doing both binomials and also proportions. So what I start with, we'll start with partner A. It is estimated that 58% of all Americans sleep on their sides. What is the probability that a randomly chosen American sleeps on his or her side? It's 58%. Then we said describe the number. So it's very important that you differentiate between number here, okay, and proportion. These are, the next section is going to be proportion. That's not what I meant to do. There we go. All right, so you have number and you have proportion. So when we're dealing with number, that's the binomial distribution. And if I were to go back in the notes, I have the feeling it's somewhere around here. Yeah, wow, I came right up to it. There's the expected value for a binomial distribution, which is n times p. That's the mean. And there is the standard deviation. Let me go ahead and highlight these. So these are the two equations that we need. All right. So now we come to the back. And so let me go ahead and write them here. There's the mean, and actually what I can do is I can go ahead and edit this and add in the equation for, here we go, give me a second, just so you have it as a reference. So this is n times p times 1 minus p. That is the formula. Let me move it over so you can see. Hopefully we're good. Pretty close, close enough. So, actually, let me see if I can cut that. I'll put it on the side here. So SD equals, and then let me see if it lets me paste. Probably not. Nope, doesn't like that. Control C. All right, let me just type it again. Appreciate your patience. So it's square root of n times p, and sometimes you've heard me call this q, which is basically 1 minus p, the probability of failure. So you need that formula right there to do this piece right there, okay? And then what we do is we check, so here I have n times p, 5 times 0.58 is 2.9. Then I have the standard deviation, 5 times 0.58 times 0.42. Where did I get 0.42? 1 minus 0.58 is 0.42. You throw that in the calculator and you get 1.10. All right, and then we know the shape is skewed left. Really, the main thing is that you just need to know it's skewed. You don't really need to know which direction. But if you did Staplet, in fact, let's go ahead and do Staplet. We know n is 5 and p is 0.58. So some of my students are like, oh, I just threw this in the binomial distribution Staplet. And I'm like, good for you. That's pretty clever. I have a lot of clever students. And I said, look, it's skewed left. And there it is. You're exactly right. And by the way, look, it calculates your mean and your standard deviation for you. But we're practicing with the formulas today. So let me go ahead and look at partner B because it's very similar, and then we'll go hit parts 3 and 4. So it is estimated that 80% of people with high math anxiety experience brain activity similar to that experienced under physical pain when anticipating a math problem. That's unfortunate. What is the probability that a randomly chosen student with high math anxiety experiences physical pain? It's 80%. Now I want you to describe the distribution for the number, which means we're doing binomial. All right, so let me go ahead and make a note here. That means binomial. All right, so binomial distribution. Now, one thing we're saying, you can use a normal distribution to approximate for a binomial distribution, but we're starting with a binomial and we need it to calculate our mean and our standard deviation, all right? Because if I give you a normal, if I say, oh, it's a normal distribution, you have to, I need this mean and standard deviation, and I have no place to start with. But the binomial has formulas for the mean and the standard deviation, all right? So we have our mean, we have our standard deviation, all right? And there it's 8 and then 1.13. So now before I start this last part, I did add on an extra bit of information onto the last question in that polling activity. So first of all, it said describe the sampling distribution. So what we did, here, let me do shape here. Shape question mark. So to check shape, you check the large counts condition. Okay. So in this example, we have in a world where 60% of all students at your school are Republican, P equals 0.60. By the way, highly unlikely in a high school because younger people tend to trend more Democratic than Republican, but this is just a hypothetical. All right. So where 60% of all students at your school are Republican, P equals 0.60, you randomly poll 30 students and find the proportion that are Republican, P hat. Describe the sampling distribution for P hat. So P hat, again, remember, is a symbol for the proportion in a sample. All right. So the mean should be the true proportion. All right. So that's going to be 0.6. Your standard deviation, this formula here came from, we had this model. So this page right here at the end of this activity, it has a nice formula and the mean, and we're going to use that also on the next piece. All right. So we calculated the mean as 0.6. Our standard deviation is 0.6 times 1 minus 0.6 right there. See, that's a formula. 0.4 divided by your sample size. I did see some students accidentally putting the 30, like here, I'm going to undo it. But so they did these numbers, but they put this, so the whole square root was above the fraction line, and they were getting the wrong answer. So be careful. The square root goes over the entire fraction, not just the numerator. Okay, and so once you substitute all this in, you should get 0.0632. And then we can check conditions, 10% condition. Fair to assume that 30 students is less than 10% of all students in a school, and we did randomly sample. You can see that we did that right. You randomly pull 30 right there. Boom, there's your random. Okay, so what's the probability? So this is the piece I added in, that our sample has less than 50% Republicans. So what you're going to do is you're going to take that mean and that standard deviation, and you go to a Saplet. And we're doing normal distribution. And all we need is the mean and the standard deviation. We said it was 0.6 and 0.0632. All right, so there's my distribution. And I know what's the probability that less than half. So to the left of 0.5, calculate area, and there it is. So again, once we can get these two numbers, the normal distribution is super easy to use. So there it is, 5.68%. So now that I've kind of gone over that, let's go through the bottom part here, 3 and 4. We're basically doing the same thing. We are, first of all, we're going to describe the mean, the shape, the mean, and the standard deviation. I did go in different order. So the mean is 0.58. It's whatever this proportion is right here. And the mean on this other one is going to be 0.8. The standard deviation, I need to know the sample size. So the sample size is 350 here, and there it's 60. So you can see there's the 350, there's the 60 right there. Oops, I didn't mean to do that. So there's the 350 here, right? And there's the 60 there. And then the 0.58 goes straight in there, and then 1 minus 0.58 is 0.42, kind of like we did in the one above. 0.8 comes in here, 1 minus 0.8 is 0.2. Then we basically put this whole thing in the calculator. And again, make sure the square root's over the entire fraction if you're using a fraction format. If you're just hitting divide and it's still in the square root, you're fine. And if you have a calculator, see if you can get these numbers, make sure you're substituting in right. Because it's a shame to know the equation, but to just plug it in the calculator wrong. Okay, so that gives us our mean and our standard deviation. Now I want to know if I can basically use a normal distribution. So that's the large counts condition. So if I do n times p, 350 times 0.58, I get 203. And then n times 1 minus p is, I'm going to say, is 147. All right, so it's normal because successes and failures are at least 10. And you're probably going, Mrs. Overman, you're running out of room. I know, I see it. You know what, I'm going to do this. There we go, that should all fit in the same problem, roughly. Close enough. All right, so it's a little bit, all right, because both are at least 10. All right, so that gets the general idea across to you. Okay, then now that we know that both of these successes and failures, so 60 times 0.8 is 48, 60 times 0.2 is 12, both of these are at least 10, then we can use a normal distribution. So then it just becomes a matter of using the staplet. Here it's 0.58, 0.026, 0.58, 0.026, plot the distribution, and we want the probability of at least 50% sleep on their sides. So I would go to the right of 0.5, calculate area, and you can see it's almost 100%. All right. And then looking at the other one, we have our models 0.8 and 0.0516, 0.8, 0.0516, plot the distribution. And we want to know less than 75%. So to the left of a value, and we'll do 0.75, calculate area, and there you go. Hopefully that's the right answer. Yes, it is, 0.1663. So again, just as a quick overview, P is the proportion, and so if you pick an individual, the probability that individual satisfies it is a proportion. When I'm talking about number, remember to use binomial distribution and use those formulas. But when I talk about proportion, the mean is just the proportion, and you have a different formula for standard deviation. And for both of these, you can make sure, if you want to use a normal distribution, you can, as long as it's normal. But see here, this one's not normal, so we have to use the binomial distribution. Whereas here, because we have larger sample sizes, we can use the normal distribution to approximate this. Once you get your mean and your standard deviation, you're golden. You go to the normal distribution staplet, and here we go. Let's see if I can get out of there. I hate it when that thing pops up. All right, and you can just plug and chug.